Do 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 do. Ice, ice, baby. Hi folks, if you have found this video, you are stumbling on part 3 of the Icebox series here. We're looking at an unknown equilibrium equation requiring the quadratic formula here today. So in the last example that we did an icebox problem. We didn't have the equilibrium concentrations, so we solved for those. But the issue that we ran into, or I guess the problem, was we got to use the perfect square formula there to try and solve that equation. So in this one here, we won't be able to use that. So given the information that we have here, we're given the equation PCl5 reacts to produce PCl3 and Cl2. And we want to calculate all 3 equilibrium concentrations if initially the concentration of PCl5 is equal to 1.00 molarity and our KEQ is 16.0. So we're going to start this question like we've started every other question thus far, where we are writing out all of our information and trying to fill that out in an icebox table. And so far, this is the best icebox I think I've drawn in this video series. So what we know is that the initial concentration of PCl5 was 1.00 molarity. We also know that the KEQ of this expression was 16.0. And beyond that, we don't know much. What we can assume is that these concentrations in the beginning would be 0 molarity. From there, we can start to try and fill in our changes here. For our changes, we know that we're going to use the molar ratios to determine whether we want to add or take away a 1 or a 2 or a 3x, so on and so forth. So for this first one here, because we have a reactant, we're going to use it up. We have a minus x here. We have a plus x and a plus x for both of our products. Again, we have a 1:1:1 molar ratio, which is really nice. And then we can fill in sort of a dummy expression for the equilibrium. And we can see that our equilibrium concentrations will be 1.00 minus x for the PCl5, x and x for PCl3 and Cl2. And then from there, what we want to do is generate our KEQ expression where we have the concentration of products, so PCl3, multiply those two together, the Cl2, and we want to divide that by the concentration of the reactants in this case. So we can start filling in some of the numbers here. We know that KEQ is equal to 16.0. We know that what we'll have here is we'll have x on top times x. Oops, I don't need the square, just times x. And then along the bottom of this equation, we'll have the filled in value for our PCl5, which is 1.00 minus x. And so you can see we're close to having the perfect square formula being able to be used again here. But unfortunately, we run into the problem where this 1.00 minus x is not a perfect square. And so what we need to do is try to isolate these x's. We'll have to do some algebra. We're dividing by 1.00 minus x, so we want to multiply by 1.00 minus x on both sides. 1.00 minus x on both sides. We're going to combine those two x's to make x squared. And then when we do 16 times the 1 and times the x, we end up with 16 minus 16x is equal to x squared. We want to get all of our terms on the same side of the equation. I like keeping my x squared with no number or negative sign in front of it. So I'm going to move the stuff from the left to the right side because we want this equation to eventually equal 0. So we'll need to add 16x and we'll need to take away 16 from both sides. So plus 16x minus 16. And then cleaning up what we have 0 is equal to x squared plus 16x minus 16. This is not an easily solvable equation. And so what we are going to do with this is, because I can't easily factor this in my head, I need to use the quadratic formula. It was very sloppy. And the quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. And so if you wanted to plug this in and chunk it into your calculator, you absolutely could. But instead, what I use is a website known as Calculator Soup. And I'll throw that up on the screen here. So this is what Calculator Soup looks like. And what that allows us to do is that allows us to plug in a variety of coefficients based on what we have. So we have a couple different terms. We have our a, which goes in front of this. We have our b, which is the 16, and we have the c, which is the negative 16. And so what you can do in Calculator Soup is you can plug in a coefficient of 1, coefficient of 16, and a coefficient of negative 16. And you can see that I've tried this question already. And then you can hit calculate, and it'll churn out two potential answers for you. And in this case, it's giving us the x is equal to 0.944 and x is equal to negative 16. So we can go here and we can say x, let's use black. We can say x is equal to 0.9444, 0.944, or we can say that x is equal to negative 16 point, I can't remember what the decimals were, 0.9443, 0.9443. And so we want to decide to use one of these two. Now what will happen is one of your answers will be bigger than this number here. And so what that'll mean, or it'll be a negative answer. So if we get a negative answer, what that means is we're losing PCl3 and Cl2, but we never had any to begin with, so it's not possible for us to lose any. So immediately we know that this negative answer is not the correct answer. The other scenario that you'll end up with is one of your x values will be bigger than an initial concentration you started with. So this would be like, let's say it was 1.3. You'd have 1.00 minus 1.3. You can't end up with a negative amount of some sort of concentration. That just doesn't work. And so we look at this 0.944 and we say, yeah, that's smaller than this number. And for these two, well, it's above 0, so we're happy with that. So we found that our x was 1.00 minus 0.944. We have x is equal to 0.944. X is equal to 0.944 molarity. And we can solve for this one to say 0.056 molarity. And there you have all three of our final concentrations. So we have all three of our final concentrations using the quadratic formula and an icebox. Again, we started with only one piece of information. And when we arrived at our KEQ expression, we said we don't have a perfect square. This term here was not squared. Even though 16 is a perfect square, this x squared is a perfect square. This one isn't. And so we can't solve using the perfect square method. So we did some algebra. We FOILed out this 1.00 minus x by moving it over to the left. Once we're able to get an expression where everything was equal to 0 on one side and we had all the x's on the other side, we were able to use the quadratic formula, and I used calculator soup to solve and get two technically correct answers of x. We know that in chem only one of those will be correct, and it'll be the one that's smaller than whatever concentration we have and is a positive number. And that is how you solve icebox problems using unknown concentrations and using the quadratic formula. Hope that was helpful.